In this lab, you're going to be investigating the energy transfer that happens when a solute dissolves in water. So what you're going to be doing is using one of these guys. So this is known as a calorimeter. It's basically a fancy styrofoam cup. It is a thick-walled styrofoam container. And the reason we use these is to try to insulate the reaction and keep all of the energy transfer inside. So by having something that's well insulated, all of the energy transfer occurs inside our container and not out into the room. Or at least we can assume that it's all staying in there with relative accuracy. Technically, a little bit is absorbed by the styrofoam itself and a little bit escapes beyond the walls of the calorimeter, but it's close enough that that amount of energy can be considered negligible in our calculations and we can ignore it. So what you're going to be doing is taking some water and adding that to your calorimeter and measuring the temperature of the water just by itself. So there are a few holes in the lid of the calorimeter you can insert. We'll be using the digital temperature probe, so you can insert one of those through the lid and into the water and record the temperature readout from the screen. Once you've got that, you'll be adding a sample of a solute into your calorimeter and allowing it to dissolve. So in order to facilitate this process, it's important that you kind of swirl the calorimeter around, otherwise your solid won't really dissolve very well. So this is helping that solid actually dissolve at a reasonable rate. And as this goes, you'll be monitoring the temperature change throughout. So you'll see the temperature start to change, either increase or decrease, depending on what solute you're using. We'll have a few different ones that you'll be doing, and that will allow you to calculate the energy change, what we call the enthalpy change of the dissolving process for these different solutes.